Assalamu alaikum students. Hope you all are doing well. In today's online class, we discuss the last topic of chapter number 9, and the topic is importance or application of equilibrium constant. The topic it is mentioned on your book page 15 and 16. Now, in the summary of the lecture, I have to revise the main points. Before going to discuss the topic, I would like to revise the main definitions of the chapter, and these are: first one, that is the chemical equilibrium. So chemical equilibrium, it is defined as in a reversible reaction when the rate of the forward reaction it becomes equal to the rate of the backward reaction and the concentrations of the products and the reactants remains constant, then it is said to be the state of the chemical equilibrium. Another important definition regarding to the topic, that is the dynamic equilibrium. So the dynamic equilibrium, it is basically the chemical equilibrium in which we discuss the equality and the concentration of the products and the reactants at the same rate. So when the rate of the forward and the reverse reactions becomes equal, at this state the concentration of the reactants and products become constant and attain the equilibrium. Eventually both the reactions, what are these both reactions, forward and reverse reaction, they attain the same rate, then it is said to be the dynamic equilibrium. So dynamic equilibrium, it is an equilibrium in which the two chemical processes continue at the same rate in opposite directions, and the ratio between the concentration of the products and the reactants, it remains constant. Another important definition, that is the equilibrium constant, which is representing by Kc. So it is the ratio. What is equilibrium constant? Equilibrium constant, it is the ratio of the mathematical product of the concentration of the products at equilibrium to the mathematical product of the concentration of the reactants. So the equation for equilibrium constant, or Kc, it is sometimes referred as chemical equilibrium expression. So it should be written as Kc is equal to products are divided by the reactants. Clear? So these are the three main definitions of the chapters. Now here I am going to discuss the topic. The topic is importance or applications of the equilibrium constant. The value of the equilibrium constant is specific and it remains constant at a particular temperature for a particular reversible reaction. So the value of Kc helps to predict. So there are, first of all, you should know that there are three main aspects or the applications regarding to the equilibrium constant. The first one, that is the direction of the reaction. Second one, that is the extent of the reaction. Clear? Here I am showing you the first of all the name of the first application, that is the direction of the reaction. Second one, that is the extent of the reaction, and the last one is the effect of the external condition on the position of the equilibrium. Clear? So before going to discuss the topic in detail, first of all you should know that what is the direction of reaction, or how we can predict the direction of the reaction. The direction of the chemical reaction at any particular time can be predicted by means of the product by reactants ratio. So the value of the product ratio leads to one of the following three possibilities. Now first of all, what are the applications? The applications are three in number. First one, that is the predicting the direction of the reaction. Second is the predicting the extent of the reaction, and the third one, that is the effect of the external conditions on the state of equilibrium. Now in the first one application, that is the direction of reaction, it also having the three possibilities which we are going to discuss in detail. So here I have mentioned the example by inserting the concentration of the reactants and products at that particular moment in equilibrium expression. So here I am taking the reaction or selecting the reaction, that is the reaction between hydrogen and iodine. It results in the formation of the product, that is the hydrogen iodide. The Kc for this reaction is already calculated, and that is 57.0 at 700 Kelvin. This value is at the state of equilibrium. These are the reactants and this is the product. This sign show the nature of the reaction. It means that this is the reversible reaction. Before going to discuss in detail the example, first you should know that what is the reaction quotient. So reaction quotient, it is representing by QC. So at any time interval, when we put the concentration of the reactants and the products in the equilibrium constant expression, we get the numerical value which is called as the QC. So here you can see that the hydrogen concentration is 0.10 mole per decimeter cube, iodine concentration is 0.20 mole per decimeter cube, while that of the hydrogen iodide is 0.40 mole per decimeter cube. So what will happen? As already we discussed that the Kc for the reaction is 57.0. So if we put these values, which are the supposed values, if we put these values in the equilibrium constant expression, so the Kc expression, it can be represented as Kc is equal to products are divided by the reactants. So here, as we are going to put the values over here, so that's why instead of Kc, here we are writing the Qc. What is Qc? That is the reaction quotient, which is the numerical value which we find out by putting the concentration of the reactants and products. So Qc is equal to products are divided by reactants. In this reaction, the product is hydrogen iodide, its molar concentration is 2, while the reactants are hydrogen and iodine, and the molar concentration is 1 each for both the reactants. So if we put the value here, we got the value that is 8.0. Now this reaction quotient, which is 8.0, according to this value, we can compare this value with the Kc of the whole reaction. The Kc of the reaction was 57.0 at 700 Kelvin. So now there are, for the direction of reaction, there are three possibilities. Number one, if the reaction quotient is lesser than Kc, it means that it will move from left to right, which representing the forward direction. It means that the concentration of product is greater over here. Clear? If the second possibility, if the reaction quotient or the Qc, it is greater than Kc, it means that it moves from right to left, means that will be the reverse direction in which the products are going to convert into the reactants. And if the reaction quotient or the Qc, it is equal to Kc, it means that the rate of the forward and the reverse reaction becomes equal. So it shows that the reaction will be in the equilibrium state. Clear? So in the direction of the reaction, there are three possibilities. With the help of the numerical, you can easily understand that how we can compare the Qc, means the reaction quotient, with the Kc of the reaction. So with the help of this, we are capable to know that how the direction of reaction can be obtained with the reference of the equilibrium constant. The second application, that is the extent of the chemical reaction. So extent of the chemical reaction means that up to which level or up to which extent the reactants are converting into products. So now again, this application having the three possibilities. Number one, if there is large numerical value of Kc. Large numerical value of Kc means the large value means the products are greater. It indicates that the reaction mixture consists of almost all the products while the reactants are negligible. Here I have mentioned another example, that is the formation of carbon dioxide, and the reactants are carbon monoxide and oxygen gas. So as a result, we obtain CO2 gas. So the Kc for this reaction is 2.2 into 10 raised to power 22. So this is the large numerical value of Kc, which indicates that there is the majority of the products while the reactants are negligible. The second possibility, if the small numerical value of the Kc, it shows that products are less, means the reaction started and the formation or the generation of the product, it also started over here. So that's why the number of the products, they are less. So it indicates that the equilibrium has established by a very small conversion of reactants into products. So there are almost all the reactants while product is negligible. It is the opposite of the first one. So the value of the Kc in the second example, which is the formation of nitrogen gas and hydrogen gas by the decomposition of ammonia, that is 3.0 into 10 raised to power minus 9. So it means that in this case there is small numerical value of Kc, which indicates that there are almost reactants and products are negligible. In the third possibility, here we are going to observe that the numerical value of Kc is neither large and nor small. It indicates that the comparable amount of the reactants and products. It means that the reaction, it will be in the state of equilibrium and the concentration of the reactants and products, they can be comparable. So for this reaction, the Kc value is 0.211. So for the extent of the chemical reaction, there are three possibilities by means of which we are capable to know that the establishment of the chemical equilibrium, it is possible or not. So the three possibilities are the large value, numerical value of the Kc, it indicates that the greater formation of the products and less reactants. Small numerical value of Kc, it indicates that there are almost reactants while the products, they are negligible. And if the numerical value of Kc is neither large nor small, it indicates that the reactants and products, they are present in comparable amount. Clear? So this is the second application of the equilibrium constant. Now the last one application or the importance, that is the effect of the external conditions. So when a system reaches equilibrium, it will remain in the same state if the conditions do not change. However, the equilibrium state of a system is disturbed if external conditions, that is, what are the external conditions? The external conditions may be pressure, temperature, concentration of the reactants and products, the volume of the system, or the presence of a catalyst. If there is any change in any condition, it will alter or it will change the position of the equilibrium. So it means that for the establishment of a chemical equilibrium, the external conditions, they also play a very important role. If any single condition it is disturbed, it will totally change the position of the chemical equilibrium. So whenever the equilibrium is disturbed by changes in the external conditions, the system always tends to restore the equilibrium. So it means that if the conditions are suitable, if all the requirements are fulfilled, so the reactants always try to make the product and the system, it tries to attain the equilibrium. I hope so the topic will be clear to all of you. Thank you.